Welcome back to Burt's Basics. My name is Peter Burt. I teach at Box Elder High School, and I'm glad that you could join us today. So, today we are doing Standard 3, so we're into a new unit today. We're into cells. And so today we're doing concepts 1 through 4, which is mostly about the cell membrane and the permeability of that membrane. All right, so here is what we're going to be learning today. So it says first we need to identify the major parts of a cell. Nucleus, cytosol, organelles, and cell membrane. Describe the cell membrane, talk about what happens with the cell membrane, and talk about the fluid on both sides of the cell. So really, out of these four, this video is mostly going to focus on the last one, which is my cell membrane. The cell has these four basic parts. It has the nucleus where it houses your DNA and your RNA, and we know the DNA is the code for every protein in my body. So if I want to make growth hormone or insulin, if I want to make muscles, if I want to make hemoglobin, which carries oxygen in my red blood cells, all of that's housed in here in my nucleus, and I have to protect it. The second part of the cell is everything from my nuclear membrane all the way to the cell membrane, which is called my cytoplasm. Cytoplasm has a ton of stuff in it. That's where my ribosomes, ER, Golgi. We're going to do that another day as well. Today we're going to really focus on this guy, this outside membrane called your cell membrane. Now, obviously he goes by many names. Plasma membrane's another one, but we're going to kind of use him as a reference, and I'm going to kind of change name as we go. So let's zoom in on my cell membrane. In order to really get your cell membrane, we have to take a trip down memory lane. I'm hoping you guys remember this. We talked about organic compounds last time in the almighty triglyceride. Triglyceride is a fancy word for a fat. So if you remember, a fat has a building block called a glycerol and then fatty acid tails. And in class, we zoomed in on these fatty acid tails to tell you if it was saturated or unsaturated, solid at room temperature or liquid at room temperature. We're fine. In humans, we kind of modify this fat a little bit. So you can still see I have my glycerol. I still have my two fatty acid tails, but man, I am missing my third. My third one's just gone. So what they do is they put on this green circle instead. That green circle is a phosphate group. But you can see he's kind of weird. He should be over here, but he's over here. Let's find out why. If you look at this phosphate group, now remember, don't panic. It looks scary, but it's not. These are your three carbons here. That's your glycerol. So those three carbons are this three carbons. Same deal, same one, okay? And then I got my fatty acetyl squiggly going down here, except instead of my third one, I put on a phosphate. He is charged, which means he loves water. And that's why our cells are so cool, because now I have a hybrid. So this red circle, my phosphate group, loves water. So that's why over here it says hydrophilic. Hydrophilic means he's okay being with water. He likes hanging out with water. He's attracted to water. That's a good thing. Down here, though, I saw a fat. These fats hate water. So that's why they call them hydrophobic. Now, we tend not to draw him like this, even though this should make sense. We make him even simpler and draw him like this. He's a head with two legs. Okay, so this red circle we call phosphate head, and then these are called fatty acid legs or tails, whatever you want to call them. Together, this guy's called a phospholipid. So that's what we're going to use mostly in our cells. So when we first discovered cells, we knew that this guy was the cell membrane. So now here comes question of the day. Which one is right? I know that in my cell, there's a ton of water inside my cell, and there's a ton of water outside my cell. So do I want them like this, where all my fatty acid tails are facing outward, or do I want them like this, where all my fatty acid tails are facing inward? Now, if you've had class before, or if you remember from sophomore year, neither one of these work, because you have your fatty acid tails by water in both cases. So neither of these are correct. I'm a jerk face like that. I tricked you, okay? Instead, they form a membrane like this, where now the water on the outside is always with phosphate heads, which they like water. The water on the inside is always with phosphate heads. They like water. And the scientific name for the cell membrane, you ready for this big word, is a phospholipid bilayer. That's just a fancy word for two phospholipid layers together. We still have a slight problem, though. That is correct. That's how the cell membrane looks. But what happens if I want to get water through this membrane? Okay, so here comes my water molecule. He's coming down. He wants to get in here. But the problem is, see all these green guys? That's all fat. That's hydrophobic. They don't like water. That's like a stick of butter. What happens if I put a drop of water on a stick of butter? It ain't going through it. Okay, so the cell has to find a different way to allow some things to go through it. And that's why your cell membrane actually looks like this. You can see that I still have my yellow heads, which are my phosphate heads. I still have my squiggly legs, which are my fatty acid tails. But then I have all these proteins embedded in it. And these proteins serve as bridges or tunnels or pipes for things to go in and things to go out. Now, later on, we're going to watch a video on the difference between diffusion, facilitated fusion, osmosis, passive transport, and active transport. That's all about how things go through this barrier. But right now, we want to talk about the basics. The basics are the following. This word selectively or semi-permeable. Permeable means to pass through. Okay, to permeate means to go through. And so it's whatever word in front of it. So if we look at my cell membrane, if I just had just the phospholipid bilayer, some things can go through. Gases, really small, they can go through the phospholipid bilayer. Carbon dioxide's a gas, some things can go through, but a lot of things can't. So they'd bounce back. That's why I have to have these protein channels to allow things to go through. Now this is really cool because the cell now can allow certain things to come in while kicking out other things. That's why we say a cell membrane is selectively permeable. It chooses who comes in and who comes out. So if I say the word freely permeable, that means everything comes through. Our cell membranes are not freely permeable. If I say the word non-permeable, that means nothing gets through. So we're in the middle. Our cells are selectively or semi-permeable. They allow some things to go through. But thank goodness we have those protein channels to help. The last concept you need to know is now that we have things going into our cell and out of our cell, we know there's water outside my cell, we know there's water inside my cell. I have to give those two names. I can't just say the water over there and the water over there. So the names we're going to give them are the following. The fluid inside the cell we call intracellular fluid. Okay, that's the water inside the cell. Another word for intracellular fluid is cytoplasm. Okay, that's all the fluid on the inside. So the fluid on the outside of the cell is called extracellular fluid. Now, I'm about to scare you, but I apologize in advance because I told you I was going to scare you. So get ready. Okay, I'm sorry. I had to, okay? I always teach in class. If you have me in my class, you know this all too well, that the reason why they call it extracellular fluid is because it is outside or beyond the cell. The same way they call this creepy looking monster man ET. He's extraterrestrial. He's outside this earth. So I call this the ET fluid because it's just scary and we want to keep it outside of my cell because that's the scariest little monster I've ever seen. Okay? So anyway, that is the end of this unit. So here is your review. So do me a favor. Go ahead and knock out these questions. Go ahead and write down your answers. The answer key's coming right up after this. And I hope you learned something. And hopefully you come back and get more video later. Thanks. Let me move my head for the answer key.